Good morning. I've got a question from Aaron. It is in assignment 2. So in part A you have to differentiate x log x. Of course we're going to use product rule. So this is nicely done and it is correct. Well done, Aaron. And then you may wonder, how do we continue? Use this result to help us to find the integral log x dx from 1 to e. Okay, so let's recall that we have this method. Okay, so in part A, we've got this result. Part A, we know that we differentiate x log x will become something very nice. We differentiate x log x will become log x plus 1. This is the result, right? So don't forget the relationship. So let's recall the story. When we differentiate a function, for example, when we differentiate a, then it becomes something new. For example, it becomes b. Differentiate a becomes b. That means when we go backward, then when we integrate b with respect to x, because it is dx, right? So when we integrate b with respect to x, then it becomes, we go back to a. Now if there's no boundary, then we have to add a constant. But when there's a boundary, say m to n, then we don't need the constant, so it becomes a, right? So this is the relationship between differentiation and integration. Now let's go back to this part. So in part A, we know that when we differentiate x log x, it becomes log x plus 1. That means that if we integrate log x plus 1 dx, when we integrate this whole thing, then it goes back to the original function, which is x log x. Since there's no boundary, then we have to add a constant, right? Okay, so this part, we could separate them into two integral. Integrate log x dx plus integrate 1 dx will become x log x plus c. Is that right? So, this is part A, we've got this. What about part B? What do we need to do? Part B, we have to find integration of log x dx from 1 to e. Do we have log x dx? Oh, look at this. We have integration of log x dx. This is what we need. And we just need to add a boundary from 1 to e. Therefore, let's add a boundary from 1 to e. 1 to e. That means that we don't need the constant here anymore. So we have x log x equals to integration from 1 to e log x dx plus one more thing, integration from 1 to e 1 dx, right? So since this is what we are looking for, we could just bring this term, the whole term, to the other side. So we have x log x minus integration from 1 to e 1 dx will be equal to 1 to e log x dx, right? Do you think that you could find this part? Do you think that you could continue? Integration of 1 becomes what? Yes, become x. So we just need to consider the boundary from 1 to e. X log x minus this guy will become integration from 1 to e log x dx. And here we just need to substitute e first and then 1 minus 1. So we have x log x minus this guy. And therefore the result should be log x times log x minus e plus 1. become this. Okay? All right.